Okay, you ready? Can you see okay? Wait, hold on a sec. So this is a system of equations word problem, which will most likely be on the SAT. Write a system of equations that describes the situation below. Solving using any method. What do they mean solving using any method? Or solve using any method? There's elimination and there's substitution, and graphing is like the one you're not going to do unless it's like multiple choice and shows graphs and stuff. Okay, so that is a way to do it, but a lot like you have to use like a ruler and stuff. All right, the Oak Grove Tigers are having team shirts made. One option is to pay Randy's team a $42 setup fee and then buy the shirts for $13 each. Another option is to go to City Printing, paying $42 for a setup fee and an additional $12 for a t-shirt. So, first of all, I also gave you a lesson involving linear equation word problems. So this is really just two linear equation word problems in one. And the big giveaway is the word, well, actually, before I get into all that, let's say, so here's your generic linear equation, y equals mx plus b. What does the m stand for? And the b? So m is, yeah, so this is your slope. This is your y-intercept. And the slope is your change. So when you hear words like um, per week, or every, or each day, you know that that's your slope. So we got our slopes here. So um, let's see. And then buys t-shirts for $13 each. So for each t-shirt, $13. And then here, $12 per shirt. There's your slope. And the setup fee, if you think about it like a word problem graphically, like what does the y-intercept mean like in a word problem? Like let's say this is time. It's like what you're starting with you before you do anything, before you sell a t-shirt or whatever it is. It's like what it is, your setup cost. When x is 0, what is that starting value? So that's your slope. I mean your y-intercept. So the first one you have your $42 flat fee and $13 each. So you have y equals 13x plus 42. And the other one is $43 setup fee, right? So yeah, so before they even like buy a t-shirt, they could buy 0 t-shirts and they still have to pay the $43, right? So so you have y equals 12x plus 43. All right, let me erase all this. Okay, so from here, um, these are kind of ugly numbers. So you're gonna want to do substitution. So if you had something like this, like x plus 2y equals 7, and um, let's say 3x minus 2y equals 5, then you'd want to do elimination. Because you could just add straight down, and the whole point is to eliminate a variable. So if you add straight down, what's 2y plus negative 2y? That's gone. You get into 4x equals 12. Oh my god, I actually designed a problem that works. And then divide by 4, and you have x equals 3. And then you plug the 3 back into one of the two, and you get your corresponding y value. That's elimination. This would not be a good elimination problem because if you stack them, they don't wipe out easily. So like you end up with y equals 13x plus 42, and you have y equals, actually that's not true. Wait a minute, now I want to do it. 12x plus 43, because look, these are both y's. So I can go ahead and multiply this by, you could just multiply like one of them by -1, and then you just distribute. That just means change all the signs to their opposites. So then you end up with negative y equals negative 13x minus 42, and then positive y equals 12x plus 43, and then you add straight down. So what do you get on the left? And then equals, okay, negative x plus 1. All right, so then we'll do, hold on a sec. So we'll do -1, -1, -1 equals negative x. So what does x equal? Yeah, so divide both sides by -1. You're going to get x equals 1. And you got to be very clear with what you assigned to your x value. So our x value, what is our x value? No, but like in words, in terms of this word problem with shirts. X is the number of shirts, right? So, okay, so x is number of shirts. Oh, and I forgot to say, what the heck? I didn't even actually even finish reading the problem. I just kind of know what they're going to ask. So when you do these systems of equation word problems, you're finding the point of intersection. You're finding the point they have in common. It's in terms of like money and stuff. It's like the break-even point. I mean, I'm sorry. It's when both of them are the same thing. Okay, so I know that at one T-shirt, your cost is going to be the same. At one T-shirt, your cost is the same. So we're gonna plug that one. You plug into one of the two equations. I'll plug into the bottom one because that way I don't have to deal with that negative y. So you go ahead and plug it in for x right there. 12 times 1 plus 43, y equals 55. Okay, so now we can answer the question. So if the Tigers, wait, so what are they asking here? The team parents chart, wait. Yeah, so it says the team parents in charge of the project noticed that with a certain number of t-shirts, the two options have the same cost. How many t-shirts is that? So they want the point of intersection. So, yeah, one t-shirt at a cost of 55. The other method substitution, so you should definitely know how to do that. It's used a lot for like break-even point type problems. Like you have a cost of something and you have revenue, and like how many units you have to sell to just break even. So, but as far as this problem goes for substitution, you're right. Hold on a sec. I might as well keep the original problems here. All right, so this right here is what letter, and this is y, right? And when you do these systems of equations, you're finding the one point that they have in common. Like that one point is, so if you, I don't know what these graphs look like, but at this point right here, which we know now, that at 155, so 1 comma 55, they intersect. They have that point in common. So does that mean that both lines for sure have what point in common? Yeah, so they have at least they have exactly one coordinate in common. So I'm going to say that these two values are the same. They have, for what I'm looking for, I want them to be the same. That's why. So therefore, I'm going to write, I'll write this problem first. Backwards a little bit. So 13x plus 42 equals y. And I also know that y is equal to 12x plus 43. So really, it's just that. You just set them equal to, you go like that. And even if it wasn't, even if y wasn't isolated, you can just isolate it in one problem and drop it into the other problem. So let's say you have like some other, oh, I'll use these exact numbers. So like, let's say you have um, something like this, like y minus 13x plus 42. All right, so I just moved the 13 over there. And then the other one, wait, I lost an equal sign, equals positive 42. And then the other one is like the same idea. So y minus 12x equals 43. And you want to, yeah, so isolate the y. So then you go like this. You go, all right, that's gone. So then y is equal to 55, 50, wait, yeah, no, I'm doing something. Oh, wait, you didn't see that. Wait, hold on. So we got, um, let me write that again. I had y minus 12x equals 43. There's an x there. They don't connect. Okay, so you have y equals 12x plus 43. There you have. So then what you're going to do is you're going to drop this in for this. So then you'll end up with 12x plus 43 because that's y. And then minus 13x equals 42. Well, okay, so I'm gonna erase all this. I'm gonna erase this and that and that. And we're gonna just compare that with what I got earlier a second ago, which is the same thing. See, 12x plus 43 minus 13x equals 42. So both these equations should be the same. To answer your question, like what do you do next? We have these guys, which are like terms on the same side of the equal sign, so we can go ahead and connect them. So you have negative x 43 equals 42, then minus 43 and minus 43, and you have negative x, negative, okay, negative x equals negative 1, x equals 1. Now you get that, you plug that into one of your originals. So you go over here, and you go, wait, here, and you plug it in for x in either one of the two, like here, and you're going to find that y is going to be 55. You like have the x's on opposite sides? No, you got to get them together because you're solving for x. You need to get x. See, so we got rid of the y's, so now we can get x. So we got rid of y, so now we can get x. And then once you get x, you drop it into the other. This problem over here, same idea. So like, the you go. Should I finish this problem off? Here, I'm just gonna erase this. Let's just finish this. So you now drop it into one of the originals. So y equals 13. This step is actually the same as an elimination. You plug it into 42. See, so then y equals 13 plus 42, and then y equals 55. And so at 1 comma 55, you got your two situations are the same. We're gonna end this lesson right now, okay? Hold on one second.